we good to go? All right. Good afternoon, everyone, particularly our online participants. Um, Apology for late resumption from our break, but now we have our facilitator on ground, and so want to start the afternoon section of this our high performance computing workshop. All right, so please let's put our acts together, and then we can start. So I invite Mr. Lauren Femi to take over from here.
Thank you very much. Hope that you're well rested and probably refreshed now. So I believe that by now everybody have everything set up from the database, right? Okay, great. So then have we downloaded Kind? We have downloaded Kind. Perfect, perfect, perfect. Okay, so I believe because most of us are using Windows, so that means we are running it. We can run it on our command line interface already. So can we just do Kind? Have you downloaded it? Have you created a cluster? You have created a cluster. So you just do Kind create cluster. So let me type the command. On your command, on your CMD, just do Kind create cluster. Yes, let me show you what it looks like. Something like this. Yes, you installed it using PowerShell, right? Yeah. Yes, just do Kind. Let me zoom in. So it's something like this. Kind create cluster. So now there's a command. So okay, let's just do this. Let's do this. It will create a default cluster for us called Kind. Just failed. So what's the error? So are you connected to the internet? Okay. Try it again. Just retry it. Is it running for is it running for other people? Is it running for you? It's running for you too. Okay, perfect. It's running for you too. I like the energy of this afternoon. He has done it since. So now I want to distract us a bit, right? That's why I want us to just enter this Kind directly. We are still going back to our image. You know, we have one image that we built earlier on. We are still going back there. But what I want to demonstrate for us, on our local machine, we have created Docker environment. We have containerized our application. So when I say Dockerize, containerize, I can use it interchangeably. So we've done that. We've packaged everything. So I can also say package. So we have packaged our image. At the end of the day, what we have is an image. So that image is now what we will move to Kubernetes. So what Kind we do for us is Kind is going to create a Kubernetes cluster for us, a one-node Kubernetes cluster. So while we run that Kind create cluster, during that time that we are creating the cluster, then I will show us just a brief overview. The same way I drew diagram on the board to explain the 3-tier server, I'm also going to do something like that for Kubernetes as well, so that we will use that time while this one is creating to show us that part. Is that okay? All right. So is it running for everybody now, that Kind create cluster? Is it running for you now? Is it failing? So this is what I will be doing. I'll be doing code knowledge sharing. Instead of me going around, those people that have gotten it will help me work with those people that have not gotten it. Is that okay? So Mr. Daria, Mr. Udeme, you can help me with that. All right. But we have actually made tremendous progress, really. We have made a lot of progress because being able to work with a Docker environment is just a step to Kubernetes. Why they are doing that, let me just come to the board and explain some things. So let me just show you a demo. Let me show you a simple demo of what I have achieved so far. Don't worry if you have not achieved that. You can see my database. You can see that I have a lot of data there. So I have a front end here, and I'm able to send my data from front end to database. So just hold on. We will still go back there. So I just want to show you what we were doing before. So this named part, I can write Paul, and for let me write a lady's name. Give me a lady's name apart from Esther. Kate. Let me use Kate. All right. So I want to check if this person is a male or female. So what's Kate's favorite color? Pink. What sport does she like? Boxing. Okay, she likes boxing. Then what would she drink? Smoothie. So let us predict. So now I sent you something. You see that I'm not collecting anything back. But let me go to my database now to go and see what was predicted. So you see that it predicted a female. Can you see this? So it predicted that Kate is a female based on these parameters. So that's what my own logic, my business logic is doing. And it dropped it in the database. I can also ask it to give me the feedback, to show it on the front end. Wait. I'm just doing a demo of what I did. We have not gotten there. No. You've not gotten. You've gotten there, but you've not tested it. What we've did so far has actually gotten you there, but you've not tested it. You will still see some 1 or 2 errors before you get here. You correct those errors and you will get here immediately. So, but I have a working application now, front end, back end, database, already working. So I will now introduce us to Kubernetes. We will set that up, then make this one work, and then deploy on Kubernetes, and that will be the end for today. Are we okay with that? All right. So let me. So the question is, technology is not just based on the name, because I noticed that even the people that are in the industry, whenever they hear Kubernetes, they are always afraid of that name. I think maybe so that's why some people call it CApIC-ACE instead of Kubernetes. It sounds so big. And let me go to Paint. Okay. So now the question is, attention please. The question is, why do we need Kubernetes? We have established the fact that we can deploy our service even right from our laptop. Whatever we have built on our laptop, we can connect a proxy server to it and buy a domain name and expose it to the internet right from our laptop. And people will be able to connect to it right from our laptop. So our laptop can be the server box and it will work. But we know that it's not sustainable. Number one, that means you have to be charging your laptop 24 hours. Everything has to be up. It's not sustainable. So we can buy a machine online, a Linux machine or a Windows machine, and put our application there. And it will work also. But we also know that when there is high volume of usage, that one too is not sustainable. We have to make sure that it is decentralized. So that's what brought the idea of microservices. Microservices. So what's the essence of microservices? Your front end is a service. Your back end is a service. Now, because we have a single back end, we call it monolith, just one. So that means all your business logic, you want to log in, you want to log out, you want to buy things. Let's say e-commerce, for instance. You want to purchase things. You want to, everything is happening inside one backend. So we call that a monolith. You might want to jot all these things down. There are some terminologies that people will say, and if you don't understand, you actually understand it, but you just don't know the name they call it. So if you know the name they call it, whenever probably maybe you are doing an interview or you are speaking to some technical people and you are dropping these words. Sorry, there's it. All right. So when you are speaking, it's good to always drop all these terminologies. People will know that, okay, you understand what you're saying. So monolith is when, for instance, we have 3 tier. So we have 3 tier. We have front end, back end, and database. Some people will put front end and back end together, and you just have the application and database. So that application is called monolith. Monolith, yes, LITH. Monolith is, they call it monolithic application. So, but now because we want to scale, and if all of us, there are companies that engineers are even more than people in this room. If you are all working on that one application, then that means there will be a lot of disarray and things like that. So what we do is that we now break that monolith into microservices. So that means I can have a service that only deals with logging. It collects your data, compared to the database. Is it the user? Yes, it's the user. Then go. That's the end. The service does not do more than that. Then I have another service that deal with carts. If you are shopping online, it will only take your order and it will take you to checkout. Another service that deals with checkout. So you can have multiple services that does specific things. That's what is called microservice. So that's your microservice architecture. So now, we don't need Kubernetes if you are designing a monolith. That's a waste of resources. Just find one single server. You can Dockerize your app and then throw it there. And it will run. If it's just a single service that you don't have multiple backend, multiple front-end, you don't need Kubernetes. Kubernetes is supposed to run a microservice. Do you understand that? You have multiple, okay, question. So you can interrupt me at any time. So I won't get offended. I'm not preaching. So go ahead, ask your question. Okay. So the way I like explaining things is to say it as a story. Once you remember the story, you don't even need to get your picture. Just understand the story. So the story is, we want to build a service that is scalable. 10 million people can plug into it and it will work. That's our goal, right? Now, for us to build that goal, for us to get there, we can start from just writing the application, front end, back end, everything more together, and we deploy. That's how most startups, that's how they start. Because it will be cheaper for you to run, it will be cheaper for you to build, and then you can do it fast and then push it out. So that is monolith. You start with monolith. If you are building today and you just want to test out your idea, you don't know if it will sell or not, you don't want to be wasting money, just put it out there. Now you have 100 customers. Everything is working fine. You have 1,000. Actually, there's a project that I did. I had about 300,000 users on a monolithic service, front end, back end lumped together. 300,000. And it worked on a single VM. And I did not Dockerize it. So it's possible. But will I do that today? No. Because anytime I want to change anything, I will have to go there, write the code, push it, the service will go down while I'm pushing, and then after it will come up. No. The service has to have zero downtime. That even when I'm changing things on the fly, you as the customer, you don't notice. You won't notice. We did a migration from GCP to AWS last year, and for a bank. And you as a customer, you won't even notice that we migrated all our resources from GCP, and we put it on AWS. We changed the backend from everything, and you as a customer, you won't notice. So that's zero downtime application. Those kind of things, you just plan it out. Once you understand microservices, you'll be able to do that. So you will understand monolith, right? So this is the understanding of Kubernetes. If you understand this process, trust me, anywhere you are good. Once you understand monoliths, now there's a question. We have thousands of users, and we need to add new features every time. We need to upgrade our application. We need to keep adding, if it is an AI product, we need to keep training our data, our model, and keep pushing the new model out every time, just like OpenAI that created ChatGPT. They keep on pushing a new model out. And there are different people working on different things because we want to make it scalable. So we decided to break that monolith up. Make sure that front login is login. It's a login service. It does nothing else apart from login. The one that takes your chart from ChatGPT, that form that takes your chart, it only takes charts and send it to the model and bring back the results. Nothing else. There's another one that deals with pricing from our Madam selling Zobo. Where is she? She went to eat. Okay. So like our Madam selling Zobo. So you just want that one to deal with pricing alone. So now you have like 6 engineers working on different services now. So all of them, you give them, okay, you work on login, you work on this, you work on that. They are designing, you have broken that monolith up. Now they are designing those endpoints, and those services will be talking to one another using an API. So once you have that kind of structure, then you have microservices. You can use Docker Desktop, not Docker Desktop, Docker Compose. You can use it you can run it on a Linux machine. The same way we are running it on our machine now. You can just buy a $20 Linux machine on AWS or GCP, then run Docker Compose with microservice, and it will work. But now, why do we need Kubernetes? You will notice that anytime we want to change something on our laptop now, we have to do Docker Compose down, then Docker Compose up, for us to refresh. But now I don't want to be doing that. I want a situation whereby even when my service is having issue, maybe there's an error and it is failing, I want the system to automatically restart itself. It should detect that, oh, there's a problem, let me restart. And it's intelligent enough to restart itself. So that's number one. Kubernetes will give you that with Kubernetes deployment. Then now, let's say I'm serving 10,000 users. I have about 10,000 people logging in every second. And my service is serving them very well. But now, it's Black Friday. If my customer base jumps to 100,000, all of a sudden, my system will panic. So they call that panicking. Not my English. So it will panic and it can shut down. That's what always happens to some infrastructure. Maybe bank or jam. It happens to them every time. That people say, oh, there's too much traffic. And so the service is slow. So what Kubernetes will do for you is Kubernetes Kubernetes and K8s will be used interchangeably. Kubernetes have this structure. They call something deployment. Deployment. I hope we are already creating our cluster, right? Okay. So they call something deployment. So see this deployment as the bag that is holding all your services. So I'm going to show us the hierarchy. See it as the bag holding all your services. So these deployments, normally we host one pod. On your Docker desktop, when you look at your Docker desktop, you can see your PHP, MyAdmin, MySQL. So all those one stuff you are seeing is like one pod each. So let's say that is serving 10,000 customers, just that one pod. Once it's Black Friday and your customer base jump, Kubernetes is able to dictate if you set there's a replica settings that you can do for horizontal auto scaling. If you do that, it can jump from one pod to 1,000 if you need it. If you need 1,000. And once your traffic is getting down, it will scale down automatically by itself. So sometimes you wake up, you check, you see that, oh, 2 pods are running. Fine, you look at your traffic, you see that you are using like 75% of your CPU and memory. It is fine. Some days you wake up, you see that about 10 different pods are running. What's happened? Then you look at your CPU usage. They are using it optimally. Then you look at your traffic. You see that you have more traffic. Then it tells you that, oh, it's because there's more traffic. That's why the pod is scaling. So this deployment has a replica set that scales up this pod. And because of this single reason, is almost like 40% reason why a lot of people are moving to Kubernetes. Because if I want to do this same thing on just a Linux machine, I have to do it manually and create multiple machines over and over again. But Kubernetes, I don't need to do that. It scales up, comes down on its own. And this pod is acting like as a single standalone computer with everything it needs is in itself. It doesn't depend on any other thing. It has everything it needs to run on its own. Do you understand that so far? So we understand the concept of how deployment works and how a pod works, right? And we also we understand horizontal pod autoscaling that I mentioned, that you can jump to from 1 to 1,000 just based on CPU, memory, traffic, and things like that. Do you understand that? Okay. So don't forget that I mentioned that Kubernetes is not just another technology you deploy for the fun of it or because the name sounds technical. It's because you are deploying microservice and you are looking for a scalable infrastructure. So number one, scalability has to be things you are looking for. If you are deploying a service for 10 people or 100 people, you don't need Kubernetes. Even for 1,000 people, you don't need Kubernetes. But if you know that you are deploying a service for a company that can have tens of thousands of customers, then the next question is, are we deploying microservice? If it is microservice and you need scalability, then Kubernetes is the answer. There are other technology. You can even deploy cloud functions on GCP or Lambda functions on AWS. You can deploy just a VM, EC2 instance on AWS. So there are a lot of technology that you can use. But for you to decide that you want to use Kubernetes specifically, it must be microservice, and you must be looking for scalability. Is that clear? All right. Why is this guy off? Oh, interesting. But I'm on the restart it. Okay. All right. So I want us to follow some. I have to redraw. Okay, that's fine. So I want us to follow some thoughts now. If I have a Kubernetes cluster here, and just following the name, because if we follow this understanding, we don't need to cram anything. I call this a cluster. What qualifies something to be a cluster? What qualifies anything to be called a cluster? Multiple things. You said what? That's members. So just like we can say this is a cluster of people. So that means for anything to be called a cluster, it must have multiple components inside of it. So on our kind, you are after installing the kind, the first thing you are doing is to create a cluster using kind create cluster command. And that will create a cluster for you. It is a one node cluster. The way Kubernetes work is Kubernetes too actually use VM. The same Linux. So when I say VM, I mean virtual machine. Virtual machine is like your laptop. Your laptop is a physical machine. So virtual machine is like a machine online. So maybe like a Linux machine or a Windows machine. Don't frown your face. Please, at any point, once I start speaking Greek and you don't understand any point, please call me back. Because I want to simplify it as easy as possible. I told you this guy is a cluster. And you understand, at least you understand your laptop. You understand that it's a machine. And you are deploying things on the machine. So the same way you have a replica of the functionality of your laptop online. Because we're talking about cloud here. So you can go to AWS now or GCP or Azure and buy a virtual machine. They have different name that they call it, but at the end of the day, they are still virtual machine, preferably a Linux virtual machine. So when you buy it, the same command that we are running on our laptop, you will run it there, and it will work exactly the same way. Exactly the same way. Nothing will be different. So Kubernetes also uses that virtual machine. But what it does is that it use multiple virtual machines. You can use one. So what we have on our laptop, that kind, is like having one virtual machine because it's a single node cluster that we are deploying. But when you are using it on the cloud, you can decide to have one node, which is one virtual machine, or let Kubernetes decide how many nodes it will need. So you don't want to stress yourself about, do I need one node? Do I need 3 nodes? You want to organize your resources and let Kubernetes decide how many nodes it will need. So cluster is divided to use multiple nodes. So this one is node 1, node 2, node 3, node 4. So just see it as I'm gathering 4 different computers together. I'm plugging 4 different computers. So whatever I'm running on one laptop, I want it to be able to run on 4 computers that have networked together. Do you understand that? So now, inside this node is now where I have my pods. So this is further divided into multiple sessions. And I have different deployments. Let me say deployment now. Different deployments. All these are deployments. So this is a node. I have multiple deployments here. So every deployment, I can now have multiple pods. So these are pods now. I can divide this now. These are pods. Now imagine before, if I just buy a single virtual machine on any platform and I deploy my app there, the app will take the entire thing and I'll be wasting a lot of spaces. But with Kubernetes, look at how many places I've divided this guy into. I can have multiple deployments, and a single deployment can have multiple instances of that deployment, which are the pods. So you see how I have optimized the usage of just one single node. So now I want to serve 1 million customers, and I am using 2 nodes to serve 100,000 before, 100,000 customers. Kubernetes can also create a new node and attach. So let's say I'm using my laptop and Mr. Dari's laptop to create the Kubernetes cluster. So it's just 2 nodes in the cluster. Once we see that we are exhausting the CPU and memory, we can add his own laptop and join, and that becomes part of the cluster. And we can keep scaling that way. We can scale. Today, every infrastructure you see, most of them, in fact, Kubernetes was created by Google. So everything running on Google today is running on Kubernetes. Today. What Google, our Gmail, our Google search, our YouTube, everything is running in Kubernetes. So now that I have created different pods, so our front end will be in one pod, our back end will be in another pod. So that's how that pod works. Then our database, advisably, I don't advise people to deploy database on Kubernetes. I will always like database to be somewhere else. But for practical purpose, you can deploy it on Kubernetes. Not to ask a question. I think you raised up your hand before I said that. Okay. So database, you have to know the function of database. What I will advise today, if I want to deploy any standardized infrastructure, I'd rather use a managed service. That means I don't need to worry myself about the deployment managing of the database. I leave it to the cloud provider. My own is just to go there, tell them I need this also configuration of database, and they provide it for me and I use. But my own service, my front end, my back end, my everything, I put it on Kubernetes because most of the time, the data inside the database is very important. And most of those cloud services, they have already solved this problem. don't reinvent the wheel. The purpose of using Kubernetes and all this stuff is because you want to build a scalable infrastructure. Most cloud services have already abstracted things like, so okay, for instance, on AWS, Kubernetes is called EKS. Who said that? Okay. Now, Elastic Kubernetes Service. There's another service called ECS. ECS is Elastic Container Service. So this is actually built with the concept of Kubernetes, but they have made it simpler. They have abstracted the problem, the stress of Kubernetes away from you. And they just tell you that you have a Docker image, bring your Docker image, just drop it here. Everything is fine. You don't have to stress yourself about auto-scaling. Kubernetes has a lot of problems that if you don't understand these basic components, it will be very disastrous. Because one day, things will just go bad. But once you understand this basic stuff and you can automate things, then you will enjoy Kubernetes very well. So many cloud providers has abstracted Kubernetes. If you are a very rugged engineer, go for EKS. But if you want easy life, go for ECS. They have abstracted all those stress away from you. So now, because of the stress of the data inside the database, Kubernetes can restart if there's any problem. And I don't want my database to be restarting. I don't want anything to touch my database. So I'd rather remove database away from Kubernetes in order to avoid it from having heavy volume, because I have to attach a volume to it. I have to do a lot of engineering with it. So instead of me doing that engineering and wasting time, then I'd rather just take my database and make it a managed service. Just like what we did today now for the MySQL. We can put it on Kubernetes and it will work. But if you are playing inside just with your computer, you can do that. But when you want to deploy enterprise grade, please don't put your database on Kubernetes. Let it be a standalone. And you can do replica, database replica, and stuff like that. Any other question before we continue?
Yes, sir. I would like to ask EKS and CS. So you said something about to make life easy, you use ECS, right? I want to believe there will be some disadvantages or some, like, because I don't know why someone on a normal day will want to go for something that will make life difficult for you.
Yes. So, for instance, hello. So, for instance, we are using Docker Desktop. The Docker Desktop is to show us so that we can see what we actually deploy. Normally, we can use Docker without Docker Desktop, and it will work. But that means you have to now run a lot of command. The same way we are using PHP so that we can see our data. If we don't use that tool, we have to run a lot of command. We are going to be saying SQL, show me database, SQL, show me. No, like, you make your life easy. So the abstraction is to give you a lot of front end that you can just click, and you get the results. But for Kubernetes is not for the faint-hearted. You have to understand the building blocks for you to work with it. But when you understand the building blocks, the interesting thing is that you cannot abstract it to your own for your own customers that want to use it, because you understand the building blocks. You can. So the disadvantage is there are some configurations that we are doing today that if you are using ECS, it won't be possible, because I don't have access to some things on ECS that I can easily play with on Kubernetes. My security especially, I can do a lot of security stuff on Kubernetes that AWS has taken care of for me. But it might not be the way I want it. Exactly. So to have that customized, but trust me, if you want to get the job done and you need to prove a point at workplace, please don't go for this yet. Go for this. But if you are now settled and they believe that you can deliver, and you now want to bring down costs, you want to make life of engineer easier, and you want to make things easier, then go for ECS. Do you understand what I'm saying? At the end of the day, the business goal is not about the tool you are using. The business goal is about the value. What are the results? Is it working? They don't care about, I use Kubernetes, so they don't care. Is it working? In fact, they will not even ask you. They will not even say how many percentage is it to finish. They just say you are in 99%, and they will ask you, is it working? You be like, I'm in 90. Is it working? No, then it's not working. That's not fair, but that's just what life is. All right. So, but do we understand this basic concept of the cluster has nodes, and then the nodes has deployments, and then based on your deployment, you can deploy multiple pods. Do you understand that stuff? All right. That's part one. Then part two. On our Docker desktop, you see that when I put something in my front end, it took the information to my back end, and my back end took it to the database. So that means three of them are talking to one another. On Kubernetes is similar. But now there's a tool, there's something that we call, let me clean this. Okay. So for this stuff to talk to one another, there's something we call service. There's something we call service. So there are different components in Kubernetes. I will only talk about the important ones that you will need. So service is what network is like, what provide the IP address for us to be able to talk to one another. So I have a deployment. My deployment is a front-end application, and I have a service attached to that deployment with an IP address and a port number. You have a deployment. Your own is backend. You have a service attached to it with an IP address and a port number. For us to talk to one another, if I want to call you, I will call your service and your port. If you want to call me, you call my service and my port. That's how we talk to one another. So that's the concept of service. I've mentioned how many things here. Number one is cluster. Number two is node. Number three is deployment. Number four is. Number five is. Trust me, this is a full course on its own. I mean, what we have learned so far is a full course that for us to even be able to understand it, do we really understand it? Like, do we really get it so far? It's a miracle. Yeah, that's good. Now, with service, we are talking to one another. We are communicating with one another. And the reason why I must share this insight is because when we now start creating them, then we will appreciate it more. So, for now, this is where we are going to, this is what we are going to create on our local machine. But now let's say you want to deploy it to the internet, and you want people to be able to speak to it, just like people can speak to it on your local machine. Then we have something called ingress. Okay. So what ingress does, just from the name, it brings data in. It is an ingress. So that's where you will attach your URL, maybe www.something.com. You attach it to your ingress. And your ingress will speak to your service. And your service will speak to your deployment. And your deployment will now talk to your node, to your pod. Do you understand? So all this stuff, they are physical machine. Your pod, your deployment, they are living inside your cluster. Then this is what is taking traffic from outside. From people that want to browse your resources. They are connected to your ingress. And your ingress is sending traffic to your service. Service is sending it to your deployments and then to the pod. So that's how you talk to a Kubernetes cluster. Do you understand this so far? Yeah. You didn't get ingress. So ingress is your entry point. If you are browsing from outside, not you that you are working on the development part. For people that want to access your service from outside, ingress is where you attach your domain name, your URL, www.whatever.com. You attach it to your ingress. So it's from ingress they will now. So once they query your URL, then it sends it to the service, and from service to the deployment and then to the pod. Then you'll be able to communicate with your service that way. Do you understand this concept now? So can we move on? do we all have our cluster created? Okay. Can you do kind get cluster? It takes so much time. Yeah, that's why I said you start since. Kind get cluster. Did you see any output? Yes, just type it on your interface. So let me do that here. I need to. I want to save it in case I want to refer. So are we able to see kind get stuff? Just a moment. So we have done kind create cluster and we have created cluster, right? So let's do kind, sorry. Or you can just do kind alone. So you will see different option. So what one? Okay. I should make it smaller. Yes. Yes. So if you do kind get clusters, you should say the name of the cluster you created. Kind. Yes, for most people it will be kind. My own, I named it to FEDGEN. Yes, I created it yesterday. So if you want to name your cluster for it to be customized, don't do that now. Don't do that now. You can do kind, so something like this. So this is the command. Kind create cluster, then dash name, then the name that you want to give it. So that's how I got this FEDGEN. Don't worry. We send a test that have all this command. And funny enough, that's URL where you downloaded kind from. That documentation has all this command. That's it there. So that's why, as an engineer, you don't expect somebody, like don't be uncomfortable when somebody is telling you everything. Because engineering problem is always a new problem. You can't expect to solve the same problem every time. Then people will not ask for your experience. Experience is how many problems have you had. So all these commands are on that documentation. The best way to understand the concept very well is to read the documentation. So things like Docker Desktop, there are a lot of commands on Docker Desktop. If you go to, just type on Google, Docker Desktop documentation, it will send you to a page. You can read, practicalize, experiment, and that's it. For kind, you can read, practicalize, experiment, and you'll be able to understand it. So this is just that. Okay. Are we good now? So something comes with kind. Let me just introduce you to kubectl. When you want to run a Kubernetes command, Kubernetes is the same everywhere. Either you are on your local machine, you are on AWS, you are on GCP, you are on Azure, Oracle Cloud, Alibaba Cloud, wherever you are. Kubernetes is Kubernetes. So, what did you say? So if you can run Kubernetes in one environment, then you can manage Kubernetes in any other environment. So, and the command for running Kubernetes is, you always start with kubectl. So kubectl, some people call it kubectl, some people call it kube anyhow, but it's kubectl, kubectl. You start with this. So with this, you can create, you can edit, you can delete. In fact, everything that we are going to be doing, we are going to be using this command. Everything that I've written on the board, that I drew on the board, our all those things I draw, we can create them using this stuff. This L. Yes, this L. So remember that I mentioned that in a cluster, we have node. Assuming I'm on AWS, I should be able to do get cluster. Let me see if this one will work. So you know. Okay. It is refused. So let me get node. And I hope it's not clashing with my AWS. It is clashing. So let me change something. Okay. So you know, this is the first time I'm running kind. I've not used it before. So all of us, we are at the same level. Wait now. Wait. And you know, I intentionally did it that way so that whatever I'm doing, we are all doing it together. I've not used kind before. I've only used AWS, GCP, Kubernetes. I've not used kind before, so I don't know how it works. So we are all going to, eh? It's just no, I'm not whining you. It's just an open source. It's an open source tool. Okay, at least everything you need is there. Everything you need is there. So let me go to the documentation because the style I would like to use is also you learn by doing. All right. So yeah, I think this is documentation. So everything we are going to be running so that it won't look as if I'm coming with one extra knowledge from outside. Okay, my internet. Okay. No, that's an assumption. So following this, please pay attention. Let me zoom it out. This is where we are. We have done kind create cluster. There's also delete cluster, but don't delete it. You can delete it after you are done. Recreate it again. Do everything we have done. All right. So now I want to run this next thing. Let us read the documentation line by line. It says to create a cluster from Kubernetes sources, you do this. Build a node image and create a cluster with this. That's if you want to create cluster from Kubernetes sources. Just a moment. Let me go to the quick stats. We've done installation. We've created our cluster. We want to interact with our cluster now. So we created cluster. So we have done get cluster. So I want to get the context. That's the context that I'm currently using is still my AWS context. So I'm going to be interacting with the context from here in order to switch the context. Sorry, FEDGEN. Okay. Exactly. So sorry, I want somebody to try it on their own local machine. Maybe it's my local problem. Sorry. On your local machine. So I want you to open the documentation page and I want you to run this kubectl in this contest. I want you to run it. Okay. No, it's not getting the contests. No, it should be kind of FEDGEN. Yeah. So do you believe me that I'm running for the first time? So I want somebody to run this contest kind. So what's the exactly? That's the expected output. Eh? No, go to your own. Don't look at my own now. Go to the documentation. So I want us to be used to the normal practice, not just like a class. So let me delete my. No, I don't want to delete it. It will take a while. Just a moment. Let me fix this. Just a moment. Okay, I think we are good. So what was the command I asked you to run the other time? No, the one I asked you to run the other time. All right, all right, all right. Okay, so you can see my screen now. Is it okay? So if you run kubectl get nodes, you should be able to see this kind control plane, right? So most of everything we'll be doing now is going to be kubectl create this, kubectl create that, kubectl get this, kubectl get that. Do you understand? So first of all, let's see everything that it has. We just do kubectl get all. So it has a service get all. So we can see that we just have a service, a Kubernetes service here, and that is it. So we want to create a deployment now and a service, and then let the service be our entry point to that deployment. Attention, I'm sure many people did not hear what I said last. I'm sure many people are already lost. Oh, you are not lost? You're not lost? Oh, that's great. You guys, is this supposed to be a tech hub? Really? Maybe FEDGEN will consider having a tech hub, really. Because I'm surprised at the way it's stressful to teach people this thing. But the way you are getting it is so amazing. I think you should give yourself a round of applause. It's so amazing. All right. So we are going to go back to our friend again, our ChatGPT friend. Because now, for us to create resources on Kubernetes, that same YAML file that we use for Docker Compose, we need to create resources using YAML files. So I will first of all create a new folder, my VS Code. So now you see, this is my code, this part. This is my code. I'm not creating it inside. Please pay attention to this. Pay attention to this. Pay attention to this. I'm not creating it inside this place. I'm creating a new folder entirely. And I'm calling it K8S. You can call it anything like Kubernetes, anything. Not inside anywhere. It's a new folder entirely. So this is you as an engineer. This folder is you as an engineer. This is you as an infrastructure person. You understand? Your linkage, your link point is the Docker Compose file. That is what is creating an image for you and that you are using. And your image is what you have on this Docker desktop. These particular things, these are your, no, this is not it. This stuff, these are your images. Like this PHP my admin, what's it called? This MySQL, this PHP, those are your images. Can you hear me? Question. I'm expecting questions. Ask questions. We will get there. That's a very good question. Hello. So, maybe we should just wait for the people that are sharing. It's not good on camera. You know, when the camera is watching and it's not good. Okay, so do I have your attention now? Please, we have to do this in the next 30 minutes. Everything we want to do now. We have done the hardest part. The most difficult part has already been done. Kubernetes is not the most difficult part. Kubernetes is just concept, which you already got the concept. So it's just for us to start deploying things on Kubernetes now. You are looking at me as if you don't trust me that it's not the most difficult part. Trust me, this is the easiest part. We have done the most difficult part. So, like I said before, we need some basic things. We need a service. We need a deployment in Kubernetes. Those are the two major things that we need. If you do get node, ctl get node. You see that it already created a node for us, a control plane node. So we don't need to create nodes separately. We already have a node. Remember that diagram that I said we need node inside a cluster. So we have a cluster, one, then we have a node. So what do we need next after having a node? Deployment. And in the deployment, we have what? Pod. And then for them to talk to one another. Exactly. So it's inside the deployment file that you get the pod. And so two things we create now. So let's go back to ChatGPT. Yes. Because I want you to make it very, very easy. Yeah. All right. No. This one is my, yeah. I should zoom. Okay. Is this okay? All right. So I'm going to put, I said we need two things, deployment and service. Deployment will take care of pod. Yeah, deployment will take care of pod. So we only need deployment and service. So my query to ChatGPT will be, create a deployment no, don't worry. I can create a deployment and service file for A8S. You can write Kubernetes if you want, unkind. That's all. So it's a short form for Kubernetes. So I just said create a deployment and service file for Kubernetes unkind. That's all. It's very simple. Like this one, you don't even need to remember. It's something that when you want to do and you know what to do, you just tell it to give you what you want. Do you understand? So it's not like I'm creating a crazy prompt. So now it says here minimum Kubernetes deployment and service YAML. I intentionally did not put YAML here because I expect it to figure it out that I need it for Kubernetes. So it's supposed to figure it out that I need a YAML file. So it created it and said I can run it unkind. This example used Nginx as the application, whatever. So we have our own application. We can decide to run Nginx too. We can decide to run our application. So let's just run this. So let me walk you through the code. I will copy the code first and run it. So it created a single file and give me a command. So let me copy the code and come to Kubernetes, create a file, and call it deploy. You can call it anything, but call it something that is closer to what you need. Deploy.yaml, then I paste it here so that I can explain this to you. On VS Code. Let me know when you are here so that I can explain this. It might give something slightly different, but it's still going to be the same concept. This is another file in a new folder. A new folder, a new file. So this one is going to work only on our laptop. We are not deploying it to anywhere. So it's just for us to be able to run some things. I just want us to have it. Are we ready? Whatever I've done so far, is there anything confusing? What did you say? No, I just created a file and I call it something.yaml. So I just call it deploy.yaml. It can be anything. You can call it KATS.yaml, anything. As long as it's .yaml, that is fine. Are we good? Can I continue? Okay. Let me drink water. So people online, are they following too? Yes. Okay. So I want to add one more thing. I want to add ingress. So I will tell my ChatGPT to add ingress to the file. So I expect it to recreate the file again from the beginning and add ingress to it. Yes, it has done that. So I'm copying this one and replacing. Okay, let me know when we are ready. Do you need the prompt? So the prompt is just add ingress. In just you've created the file, the deployment and service. You've pasted it in a new file. So just tell ChatGPT add ingress. That's all. So it will recreate the file afresh for you, and it will add the ingress. Yes, replace. Yes. Are we good now? For the so the prompt is, let me just scroll there. Create a deployment. So let me edit this prompt. I will just put the ingress here too. Create deployment service and ingress. No, 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 no. It's for the people online. So I'm just recreating it again for people online. Yes, with ingress. So deployment service ingress in a single file, bucket, on kind. And you know my point is, I don't want us to look at as if it is the special prompt I gave to ChatGPT that gave me this result. It's just what I want to see. I have a goal I want to achieve, and I'm asking it to help me achieve that goal. So when you are doing your own, it might be deployments you need, only deployments. And later you need a service. Later you need an ingress. Later you need a load balancer. Later you need this, you need that. So it's based on what you want that you just tell the AI and it will give you the result. Hope you are clear. So it's not about the prompt. It's about what do you want to do. Talk to the AI will tell you the next thing you need to do. So it creates this for me. Good, good, good. Let me replace it again. All right. Are we good now? Can we continue? All right. Yes, yes, I've deleted it. Okay. So if you are good, so everything we need to run now, pay attention to this. From my terminal, so this is my new terminal. I want to So I want to go to, I created a new folder. So because my code is on one side, this is my Kubernetes code now. I want to go inside my Kubernetes code. So I'm right clicking and open in integrated terminal. So I should just go to that place directly. All right. So if I do ls or dir, I should see my deploy.yaml. Right? Good. Let me see if I can run my kind there. Or my qctl. qctl get node. Perfect. Right in my VS code. So I don't need to go to PowerShell. Yes. So I created this 16 minutes ago. So I destroyed my former FEDGEN cluster and recreated it again. No, it's just to be on the same page with everybody. And that one was misbehaving. Yeah, question? Yes, I replace it. I use this one to replace it. Okay, so are we here? Are we inside the folder now? You're inside the folder. And you can see your deploy. You can see, can you run kubectl get node? And it's working. Perfect, perfect. We are doing well. I'm happy with this class. Okay. So now we want to apply. If you do, let's check something first. Three things. So let me explain the code and then we'll do an example. Attention, attention. Do I have your attention? Okay. You will see that there are three different levels in this YAML file. The first one, you can see that this kind is deployment. We have a deployment. Then if you scroll down, the deployment has some metadata or something. Then you see this dash, 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 dash. Then you have another one called service. Are we following? The madams there are not following. Okay, thank you. And if you scroll down, you see some dash, 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 and you see a third one called ingress. That's the final one. So you have those three blocks. You can divide this thing into three different files. But Kubernetes we are able to push everything inside a single file and just separate them with this dash, 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 dash. And it will work. You have two. So you can combine the two. Does any one of the two have these three blocks? That means you do not. So put the ingress command. Yes, ma'am. It came with the code. So it's just to combine the three. It's supposed to be three different files. Because we are just. Yes. So, but we just want to push everything together. All right. So if you are following, please, how many people are following so far? You guys are trying, Like, I'm still amazed. Well done. Well done. Well done. Yeah. The other people, are they following too? And they are following? Yeah, please, let them give a thumbs up if they are following. Because I'm amazed that you can follow till this stage. I thought maybe when we get to a stage, everybody will just run away. Okay, for the online audience, if you are still following, just give a thumbs up. Okay, they should snap their solution and as evidence. All right, all right, all right. Well done, everybody. So remember something. I'm inside this directory now. This new directory. I want to run a command. This command, is just kubectl apply this file. That's what I want to run. But so that you won't think it's just living in my head. ChatGPT already gave it to you. So if I scroll down, you can see kubectl apply something, something, something. You understand? But this is if you are installing from outside. But that's not what you want to do. You want to use this one. This one, kubectl apply, then the name of the file. So it's kubectl apply -f, then the name of the file. Yeah. Yeah. a lot of VS Code. Then you go to the directory. No, 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 no. We can use the terminal on the VS Code. It's still the same terminal. So let me explain something to us. Um, Let me explain something to us. Will I explain this? Your image currently. Okay, when we get there, we solve the problem. So I want to do something. Let me do it. Let me do it. This particular one. You follow by doing the same thing I'm doing, and then, do you have this part in your ChatGPT? This one that is long. Exactly. So you remember that we packaged. Wait. So when we asked it to create this deployment for us, it will tell us how to run it, and it will give us this sample code. QCTL apply something. Do you have this one that is talking about ingress, engineers ingress? You have it. And that's what I'm saying. So this engineers, oh my, this engineers ingress is what we create. We help us create our ingress. It's called an ingress controller. You have to pay attention. I like that lady. If you want to be distracted, she told the guy, wait. So we have deployment file, service file ready. We can run it and it will run. But now for our ingress needs Nginx. Remember that when we were deploying something, we're using Apache. Now, our ingress here also needs another server. Now it's not using Apache, it's using Nginx. So we first of all run this first line to create the Nginx in our environment. So let's copy that first one. That the long one. Thank you. Make sure that you are running it. Well, anyway, it will run. So just paste and run. So this one, what it will do now, there's a deployment file that is already written by Nginx somewhere online. And we are just deploying that one directly. We can see, if you follow this URL, we can see the deployment file. Well, let me see if I can check it. Sorry, I want to plug my laptop. Let me know if you are able to run that long stuff. I want to change my internet here. Just a moment. Let me. So how many people have run that long one? And it's successful, right? Can you do kubectl get deploy? Kubectl get deploy. I'm still trying to. get deploy. I'm trying to run it from here. Have you seen it? Eh? No resource file. Get deploy. So let me type it. Let me type it. Just a moment. This is what you are run. Oh. Hey, this guy is kubectl space get space deploy deploy. Kubectl get deploy. Yeah, it has spaces. So what do you get? Get deploy. Yes. Yeah, that's fine. Okay. No, it's supposed to show. So now do kubectl get all. Yeah, it's okay. I don't know. Maybe somebody should help her check. Yeah, it's fine. So can you do get all? kubectl get all. What are you saying? And it's only one you are seeing there. And you've run that long one successfully. Interesting. Bring your laptop. Let me see what you are seeing. Okay, so listen, please. Everybody listen. Listen. That kubectl gets all. Then put space dash capital A. After all, then space, then dash capital A. That dash and capital A, there's no space between dash and capital A. Just dash capital A. So you see the list of all the resources. I'm still trying to, that stuff you have downloaded, I'm still trying to download it. Let me change my network. All right, perfect. So now let me show you what you're supposed to do. kubectl gets all dash A. Can you see it? This is the command here. Dash A. Then press enter. Then it will show you many things. So now you can see that it's actually many things that it has created. Yes. You can see something, if you go to the beginning, you can see something like pod slash. So you can see that it's creating a pod for you. If you down, you can see something. Now, this is just for the ingress controller. So I will hide this one. Then I want you to also check something. Do kubectl get ns. Ns stands for namespace. It stands for namespace. The meaning of ns is namespace. kubectl gets namespace. We see this list. Now, this second one is our Nginx. When we ran that Nginx initially, it's created a namespace on its own, and all its services, he added it to its namespace. Please, Pay attention to this. Pay attention. Pay attention. Pay attention. Pay attention. All right. You know, earlier on, the image I drew, I said we have a cluster, we have a node, then we have deployment, we have pods, right? That's the normal way things flow. But in order to further optimize, because there's some situation where we now have multiple environments. What I mean by environment is whatever we are creating here now is our development environment. See it as you are an engineer, you have written a code, you want your engineer to push it somewhere to test, or just for people to be able to test the functionality of your code. You push it to your development environment. That is not where your customer is or are, depending on how many customers are you serving. Please, are you paying attention to this? Whatever you have built, the first place you push your code to is not to your customer. You are pushing it to a development environment. For your engineers, for your QA, people that are doing quality assessment, quality control, for them to go through your application, make sure that everything is working perfectly well. After that, then you, actually it's just for the engineer majorly, the dev environment. Then, depending on how rich your institution or organization is, you can have a staging environment or a UAT. UAT stands for user acceptability testing. You can call it UAT, you can call it QA, you can call it staging. It depends on the nomenclature your organization wants to adopt. You can also call it pre-prod. So that one is like your production environment, but now you want to make sure that there is no error. So people have to rigorously test it. For instance, the application that I designed the other time, I said, let me show you a typical example. If I go to this application now, where is it? This app. You would think this is fine and it's ready to go. No, it's not. It's not. Number one, the tests are just flying around. It's supposed to be well arranged. So that's part of quality control. Then number two, check something out. This is supposed to contain my name. I can decide to put number and alphabet and anything. Normally, there's supposed to be something that checks if I'm putting the right things there. If I ask you to put age, you shouldn't be able to put letters. So all those stuff is quality control. It happens on your staging environment. So now, the reason I mentioned dev, staging, and production. Production is where your customers are. Everything you are deploying on your environment, you can deploy 10 iteration on your dev environment before moving to your QA. QA test it, they find a fault, they return it back to your dev. Correct that fault. You design it, treat it, take it back to QA until they are satisfied. Then you now tell the business you are ready to go to production. All this process have to be automated. It has to be machine making those decisions. In fact, today, machine does that QA. It looks at your front end, tests it with different scenarios, puts letter, puts number, put apostrophe, determines if it fails, it returns it back to you. You write the code. It's also machine writing your code for you because you are now using ChatGPT. So machine is doing everything today. And when you are done, it's another machine that will take it to production. And very soon, machine will even be the one ordering. If you are on Jumia, very soon, machine will be the one ordering on Jumia. There's things that they call agents today. So very soon, your agent will be the one ordering for you. You will be the one booking your ride, be the one paying your school fee and all those stuff. So let's go back to this. Why do we need namespace? Namespace, we use it majorly to logically separate similar things. I don't want us to, whatever I'm going to say is not a big deal. That's what I'm explaining. So you can see here that this is default. We have default. Anything that we run and we do not specify namespace, we automatically come to this default namespace. So every work that we deploy here, we automatically come here. But you remember that if we run Kubernetes, kubectl, let me show you the difference between this namespace now. Get deploy. This is what you are getting. No resource found, right? Because this guy is looking at the default namespace. Now imagine I now put something like dash n and I put this namespace. You can see that I see something. So that means I'm telling it the deployment I want you to check, go to ingress nginx namespace to look for it there. It's a logical separation. It separates workload in a namespace and abstract it from another namespace. Do you understand? Do you understand? I can go over it again. I should go over it. So let's assume I have a dev environment. You know, I mentioned multiple environments. I can have them on different clusters, on different Kubernetes cluster. But our company, we are a startup. We are managing money, and we are running microservice. You guys understand my language now, right? Good. We are running microservices and want to scale. So we want to start building microservices from scratch. And we cannot afford to have multiple clusters. What you have done today, you can deploy it on a VM and have a cluster. You are the one that created your cluster, but you want to use a managed cluster, so we cannot afford multiple clusters. So instead of having multiple clusters to deploy your dev, staging, and production environment, you can use namespace to logically separate them. So going back to my, I hope this stuff will not restart again if I go back to paint. So if I go back to that paint, just imagine that paint that I drew the other time. I have a cluster, I have nodes, and I have deployments. You know, that deployment, if I say this deployment is my dev deployment, I can create another deployment of the same kind, allos paracletis, of the same kind, and put it in another namespace for another set of people entirely. That's why, for example, the Facebook we use in Nigeria is different from the Facebook they use in the US. Even if you go to Facebook, especially TikTok, that one is even obvious. If you go to China today, the TikTok in China is different entirely. Even from the interface, from the experience, it's different. Because they are able to separate different users based on where you are coming from. Okay, so there's some websites. Let me give you an example of this website. Let me give you an example of this website. Okay. Yeah, accept the cookie. Now look at something. So this is one of the companies that I work with. Now, for example, now you can see that this place is writing global. If I'm in the UK, it will automatically dictate that I'm in UK, and it will look at the content. You can see that the content is different, but the address is not different. It's still the same address, but the content they are serving us is different. If you are in UK, it will serve you this content because everything on this content is reading pounds. You can say pounds, but if you are in Nigeria, it's reading naira. Yeah, go ahead. Yes, they call it localization. So you want your audience to feel at home. If you go to google.com, so you will notice sometime if it is Independence Day, it will change this to Nigerian flag. So they are trying to localize so that you will think Google built a new Google for you. But so in order for you to do this, you can do that at the application level, where you just dictate where the person is from and then switch at the application level. But in order to manage infrastructure, let's say people in Nigeria are paying more than people in Ghana. So you want to put enough resources in Nigeria, more resources. So through your namespacing, you can logically separate everybody. So it's just for you to understand the concept. Somebody asked about namespace the other time. So do you understand the concept of namespace? All right. So now, from here, remember that the command we ran is the first command. We have two commands from our ChatGPT. We ran this first one, and that's what gave us Nginx. Nginx ingress controller is the one controlling your ingress. So now this one, we now want to run the main one that will run our deployment file. So we do this, and the name of my deployment file is deploy.yaml. YML. So I wrote kubectl apply -f, then the name of my file, provided I'm inside that directory, this KTS directory. So you have to be inside your own directory and then run this and then put the name of your file and then enter. Immediately you see that it's created a deployment, it's created a service, and it created an ingress immediately. So if I now do get deploy now, that get deploy that is saying there was no resources, you can see that there's now two resources that is trying to start. Do we understand? We are inside Kubernetes now. You see that's difficult. Who needs help so that we just address it? Yeah. Yeah. What kind of error? Let me see. So just give it this way. It will show when it starts. Okay. So if you're having the issue, just do kubectl get deploy. Check if it has actually deployed. kubectl get deploy. Beautiful. What? Is it deployed? So did you? I'm sure. I'm sure it's probably something that has to do with the directory. Are you inside that directory? Okay. So how many people actually see the deployment after doing get deploy? You are flowing well. Okay, you are beautiful. What about him? I've seen it. Okay, great. Let me see. Let me see where your deployment file is. Okay, so we are wrapping things up gradually. So let me just recap. Let me just recap and tell you how everything synced together. Hello. All right, all right. So remember at the beginning, we created a sample app, deployed it on Docker desktop, and I've shown you can interact with it on Docker. We have an image. So now what we are deploying here, we have different images that we are deploying. But the test image that we are using for Kubernetes is Nginx, an Nginx image. So this particular image part can be the image that you have under your Docker. So let me show you this. If you come to images here, you can see that here I have MySQL, I have PHP, and multiple other images. This can be the name of that image. So me specifying Nginx, it's just like on your Docker desktop. Let me show you something on Docker desktop. You can come here and search for anything. Here I search for Olama. If I click pull, that's, remember the Docker Compose that was pulling. I don't actually need it. I can come to Docker desktop, type anything I want to get here, and pull. I can type WordPress. We know WordPress, right? WordPress is used to design websites. And I can pull WordPress, and I have a website that I can start building. So whatever I'm putting here is what that stuff we build. So let me, so if I come to WordPress, let me even click this and copy the WordPress image. So with this WordPress, you can build any website you want to build without writing code. You just do drag and drop. Just okay. It's just Docker pull WordPress. So if you run that Docker pull WordPress on your local machine, it will pull WordPress to your Docker stuff, Docker desktop. Image is just WordPress. So the image I'm using here is Nginx. Let me change it to WordPress. And then I just change it on this image, on my deployment. Yes, you can, any image is fine. But now this image has been stored. So the process is, once you have built your image, you throw it on that account that I asked you to open, this docker.io. Remember I asked you to open docker.io. Then you will send it there. Just let me practicalize that for you so that it will be easy for you. Let me go to this place. ls. So if I do docker ls, no, docker, let me do docker help. Sorry, double H. So I want to do docker, no. Docker images. Docker images. Now look at the response that it gave me. It gave me this list of all the images I will naturally see here. So now from here, I can do docker push. Then the name of my image is PHP. Where is it? That code that I wrote in the morning, the name is PHP. After packaging it, I called the name PHP. So I can do docker push PHP. Let me give you the tag. Latest. Push docker library tag. Okay, sorry. Let me tag it. Docker build. Let me do docker in it. Yep. Just a moment, though. I have a Docker compose. So I want you to build a Docker file for me so that I can push it to the desktop. So once I push it to docker.io, anything that I have built, you will be able to access it and download it to your own end and then run. So the same way I can pull Nginx, I can pull WordPress. Once I build an app, I can package the image and send it to docker.io. Then once I give you the name of that particular app, you can then go there and pull it and then run it. So that's how we collaborate. Let me come again. Everything that we are doing, I told you that multiple engineers are working on multiple things. I have built something, you have built something. We need to collaborate. It's on my laptop, your own is on your laptop. Our meeting point is two different places. We can meet on GitHub. we can push our code together and meet on GitHub. Or if I'm the one building if I'm a different organization, I can just build my own Docker image. After building it, I'm going to package it like this and then send it to Docker Hub, which is where this Docker desktop gets all those images from. Once I send it to Docker Hub, you can go to Docker Hub and pull my image. So you'll be able to run my application locally on your own local machine. Do you understand? So that's how we collaborate. Either we collaborate in our code on GitHub, or if you are building two separate things, you can pull my image and use. So because he said that we should use that same image that we built in the morning, because I just want us to pull WordPress, we run it on Kubernetes, and that will be the end of today. But yeah, so we want to push it to Docker Hub now. So once we push it to Docker Hub, on your Kubernetes file, your Kubernetes deployment, you just come and specify the name of the image here. Image. This line that says image, everybody has it there. You come and specify the name here. So once you specify it here, then you go to Docker Hub and pull it, and then it will deploy for you on Kubernetes. Yeah. So the purpose, the reason I have to put it to Docker Hub, if I'm running it on Docker desktop, Kubernetes is not for local environment. Yes, kind is for demo. And once you want to use kind on Linux machine, for instance, maybe you have like one organization machine, you are going to be accessing it remotely, and you need other people to gain access to it. If it's just for our own local development, we will stop at Docker. We will not go to the Kubernetes, because Docker is enough for us to do multi-service, microservices, and it will work fine. But anything that makes us go to Kubernetes, we must make sure that we are demoing it the same way it will work in the industry. And in the industry, you have an artifact registry, which is your Docker Hub. So your image is also called an artifact. So when you put it on Docker Hub, then anybody can have access to it and pull it from there and use. And also you can be from your organization. When Kubernetes restarts, I told you that time that if your application is faulty and Kubernetes go down, it can restart itself. It's going to go back to that registry to pick the latest image. Also, when you are deploying a new service, let's say you made some update to your service and you are deploying it afresh, what Kubernetes will do, it will not drop that old one. It will create a new pod, make sure that it is working and running fine, and then send new traffic to it and then kill this old one. So two things that we want to do to wrap everything up. The process of creating an application, Dockerizing it, we already understand, right? Right? All right, good. Now, the second process from our, let's stop Docker in that stage. Then from on our local machine now, we can create a Kubernetes cluster that already has a node. We can create deployment. We can create services and ingress just with that single file. We are good on that side too. So now what we need to now do is take the image we created on Docker desktop. I don't want us to say Docker desktop, because Docker desktop is just an interface that we created using Docker. We will throw it somewhere online and then ask Kubernetes to take it and deploy. You get? So that ends the entire life cycle. So let me show you one thing. Let me go to another. Okay, this is my Kubernetes stuff. If I do, and this is one of the beauty of Kubernetes. If I do get deploy, you can see that there are two things. It's showing 2/2 ready. That means this, assuming that I did not pass through that online route, that I did not put my service online and take it on Kubernetes. This is the one that is already online, which is Nginx. I just pull Nginx and then run it on my Kubernetes. Let's say, for instance, somebody now mistakenly destroyed my pod. So this 2/2 means 2 pod is running in my deployment. How did I come about 2? If you look at your deployment file very well, there's one particular place that says replica set to be 2. If this replica 1 is fine, it means that only one copy of your application is running. Then That's where scaling comes in. So if traffic, so this replica set means let the maximum be 2. Run 2 at this particular time. I don't want to overwhelm you. Can we add one more thing to that, to this? Can we add just one more thing? Yes, to this deployment code. that one more thing is what do the auto scaling. It's called HPA. Okay. Yes, yes. So now I will say create HPA file. That's all. Create HPA. It means horizontal pod autoscaling. So why this one is creating, let me explain something very well. This place, I put 2 as my replica set. That means at any point in time, make sure that 2 pod is running. At any point in time, nothing less than 2. So if I come here and do CTL get pod, I used to do get deploy. Now I want to see the pods. You can see that I have 2 pods. My SQL, my app deployment, my app deployment, there are 2 pods. So at every point in time, these 2 will always run. I want to delete one of them now. See what Kubernetes will do. I will say kubectl delete pod, and I will specify the pod I want to delete. Remember, these pods end with BF. Just notice what will happen. No, there has to be space here. So I'm asking it to delete this first pod. So I'm saying kubectl delete pod, this particular pod, and I'm pressing enter. And it says pod deleted. Now let me go back to Kubernetes get pod. Do you notice anything? Immediately. So that's what Kubernetes will do for you. If you go to anybody's server now and go and delete somebody's resources, they will shout. But Kubernetes, you delete my pod, Kubernetes will restart it immediately. So if your service goes down, as long as it's just infrastructure issue, Kubernetes will start it immediately. But don't delete your deployment. Oh. You are telling me that I really want to get rid of this guy. But if it's the pod, so I asked you to create horizontal pod auto scaling the other time. And I want to add this now. So I will add this to my deployment file. I'm not replacing now, I'm adding. Just a moment. Okay. So at the end of my deployment file, I'm putting 3 dash and then copy and then I will paste that one there. All right. I asked it to give me HPA stuff, right? So that HPA, I can actually just copy this stuff, put it in another file, and then run apply. The same way we did that apply the other time. But I want everything to be inside a single file so that we are not overwhelmed. So I just say create HPA file. That's all. HPA is horizontal pod autoscaler. I have 2 pods, but I am asking this guy to automatically create multiple pods depending on this parameter. This guy is using CPU to determine when it will create another pod. So, and he's saying that average utilization should be 50. So that means he's targeting 50% usage. Anytime my pod is getting to 51%, he creates another pod and share traffic to that pod. That's what this guy does. So once you add this guy to your stuff, just run kubectl apply again. Then you add this one to it. Do you understand? With this, you have a very robust infrastructure. With this, you can run anything and go to sleep just with this. Do you understand? Are we good? Can we end it here? So what's the last part? So what's the last part you want us to cover? For us to drop it online and then great. So let's package the file. Yeah. after adding the auto, okay, so let me just conclude that stage. Apply. After adding the horizontal pod autoscaler, you just run this kubectl apply -f, then the name of your file. Yes. So you notice something? He's writing that this is configured. Deployment does stuff. So if I do kubectl get HPA, now it's telling me something here that minimum pod will be 2, maximum pod will be 10. So that means it will keep on scaling up those pods depending on CPU until it gets to 10 pod. So I can put 1,000 here. It will keep on scaling up to 1,000. Now imagine what will happen if I change this guy to 1. My replica set is saying 2. If I change this guy to 1, horizontal pod auto scaling, if I change it to 1, and I rerun this guy, and then I say get deploy, get pod, for instance. So it's creating a new container. Then let me say get HPA 1. Okay, so let me do get pod, get deploy. Sorry. Now you can see that my deployment is still 2. So that means whatever I specify as my replica set, we override. So if my replica set is more than the minimum, it will take my replica set as the minimum. But if my replica set is reading 1 and my minimum in HPA is reading 2, then it will always take my HPA. You understand that? So HPA is for elasticity, for scalability, the elasticity for it to go up and go down. While replica set is the barest minimum you can take is this particular amount. You can also set your HPA to 0 if it's not a critical service that the service can go to 0 without anybody using it. You can scale it down to 0 so that you don't waste resources. So do we understand this now? Everything you have done so far is what you need to know as a mid-level cloud engineer or a DevOps engineer. Either you are working as a DevOps or a cloud engineer or SRE. With this knowledge alone, trust me, you are a superstar. And I'm not making mouth. There are a lot of people in the industry that they don't know how to create. Whatever we have done now is not a big deal. And it's even easier if you are using AWS and GCP because you don't have to use kind. They have already given you the service already. Your own is just to plug into it and run all this kubectl get stuff. That's all. So you are just running YAML files. That's all you are doing. Everything about Kubernetes, you are just running YAML files. You apply it, you change some value, you apply it. That is all. Nobody is doing any other thing extra. That is all. Do you understand? Do you believe me? It's like some people are looking at me like they don't believe me yet. It's not even agricultural science. You know, agricultural science, you still have to know the amount of fertilizer, the amount of. But this one, you are not stressing yourself. And people, how will you give me a lot of money if I don't make it look big? When I'm talking, so now that I'm just saying Kubernetes, no. If I'm talking in a business environment, I'm not saying Kubernetes. I will use a base voice. Actually, the Kubernetes. And so you that are hearing it, you are afraid like this guy must not go. If he goes, all our infrastructure will be destroyed. I'm serious. That's what's happening in the industry. People paint little concepts. Look at what you have done today. Is a 6-month course already. Whatever you have done today. And you did it within the day. Exactly. No, don't register for that yet. Practice more. So with kind, you can do a lot. And you can get certification. In fact, you can start practicing this and then go for all those GCP, AWS certification. And once you get that, just apply for any roles to test yourself. At least go to their interview and hear what they will ask you if you have the answer. That's the best way to test. Hear what they will ask you. If you have the answer, then you know that, I know something. Then you go back to ChatGPT. Go back home and then go do it again. Because most of the things that happen, because I've sat down where people are doing interviews, and I know that people did not give time to understanding concepts. They wanted to understand technology without the concept. So I can come here and start from Kubernetes and then start running YAML file. You will be struggling to understand what I'm doing. But because you build something starting from the application you want to deploy, and you are able to package the application, you are able to put it somewhere online, get it, deploy to Kubernetes, scale it up, scale it down, get the service, get the ingress. That's all. That's all what everybody is doing. So that's just everything. So the last one, as just the bonus, is just how to push and then pull. That's all. From Docker up. Those stuff that we were pulling in our Docker, have to now push that Docker up and then pull from it. That's all. So you don't pull from it directly now. You pull from it from your Kubernetes application. So, but are we good? As at this stage, we are done with Kubernetes. So, yeah, we will push it. No, 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 no. What cloud charge you? So what he asked is, if you are scaling your services to multiple pod, will it affect how the cloud provider will charge you? So remember that I said when you have your cluster, have nodes, and your nodes are virtual machines. So is that virtual machine and then the managed Kubernetes that they gave you? That's what they are charging you for. The managed Kubernetes is really cheap, but the virtual machine, if you are running a big machine, the price. So it's the price of that machine they're actually charging you for. But they have already packaged the Kubernetes for you. Instead of using kind, you are now using EKS or GE for Google or EKS for Azure. So that's what they will be charging you. And most of the time, when you have a mature engineering team, it's cheaper to run Kubernetes than to run multiple servers. Because multiple servers, you have to deal with linking all of them together. Your scaling, you have to configure it separately. Or Kubernetes, you just have to run YAML files. And your YAML files will take care of the whole thing. It makes life very easy. It's a rigorous concept when you are not discussing it like a story. But if you are able to tell the story and understand the story, then that's all you need. You'll be able to explain it to another person. I'm sure if I start asking people questions here now on system architecture, you'll be telling me stuff. Should we try it? No, 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 no. We have to test knowledge. Okay. Before we say that, let's quickly push our Docker image online. We have not done that. So let me go back to my directory. Let me shut this one down. And I can do Docker PS. So I can do Docker. Let me tag this stuff. Let me see if I can tag it directly from here. But I have to rebuild this. Let me quickly rebuild it and build it with a tag. Docker build. Oh, interesting. Docker compose. I want to see if I can add it. Let me see if to add a tag here. What's the name? PHP service image is. Let me tag my. I want to tag my stuff from here. Docker command. So pay attention to this. We want to push our Docker image to Docker Hub now. Please, you have Docker Hub account, right? Okay, if you don't, I'll quickly register while we are doing this. So let me log into my Docker Hub first. Docker. I'm logged in already. Okay. So this is even looking like our normal Docker desktop. Let me. So you can log in to Docker Hub from here too, from your Docker desktop. Yeah. You can see that I have some stuff here. Yeah, yeah. Just go to images. Then you see Docker Hub repositories. I hub. Okay. Check it. But remember, I'm logged in. You can see my initial of my name. So make sure that you are logged in. You are logged in. Okay, okay. So can you create? Yeah, you can do that. Let me see what you are saying. I even have a better way. Give us the you try to create your own account. So everybody, I think the easiest way is come to your image. This is my image here. This PHP is my image. Remember, I come to image, then I selected this PHP. You can see these three dots here. Let me expand it. Yes. This is PHP. Then I have these three image here. If you click it and click push to Docker Hub. What? Failed commit on ref manifest. So let me see the error. Message insufficient scope, authorization field. Let me see if I'm still logged in. Let me sign out and sign in back. So just solve the authentication issue. Just try to sign out and sign in back. That would be easier. I think you are logged in with Google. Sorry, I have to do something. Sorry, Okay. Let's use command lines like this guy is. Let's just run command docker command docker push. You'll be able to do it there. My own is running is showing me an error. I want to do it from the command line. Command. So what I asked everybody to do, he has been able to do it. This is my PHP here. Let me reduce it. This is my PHP that I want to push. The code that I wrote. So these 3 dots here, once you click it, you just do push to Docker hub. Yes, mine too is giving me error, but he has done his own, and I want to do my own from the terminal now, instead of using it's saying insufficient scope. So let me just push it directly using this thing. Push command with tag. Let's do this on the. I've already created image. Okay. Yes, you have to log in. Okay, we have a tag there already. Interesting. So this is what I wanted to do. I did not see that it's already here. You can see this tag. It already has a tag 8.2-Apache. So I think it got that from here. 8.2-Apache. Yeah, that's fine. So let me just run this command now. So, so what I put here, I said docker push. No. I want to push the code that I built. No, it's the image, the code that I built on Docker Desktop. So I want to I've packaged it as an image. So I want to push it to Docker Desktop. Docker Hub. On Kubernetes. Yeah, so I don't want to run WordPress. I want to run my own app now. So now, I want to first of all push my image to Docker Desktop and then pull it on Kubernetes. Yeah. So that's actually the last part. Sorry, Docker Hub. So I just said Docker Hub command with tag. So I need to tag it first, which has already been done. So I just need to push now. So I push with the name of, let me do this, Docker tag. So this is the command for doing that. Docker tag. Then the registry URL and then repo name, then tag. So if you go to, if you check here, I have some here. Yeah. No. You have done it already now. Have you logged in? Can you do Docker login? Okay. So what's the error that is giving you? Okay, so that's what I want to do from my end first. So I want to tag this PHP first. The name of the app is PHP, and this is the name of the tag that it has. So I want to give it a tag that I'll be able to run online. Are you following? I hope others too are following. PHP, then tag. What I just did here is Docker tag, the name of my application, column, the name of the tag. I got my application name and tag from Docker desktop. This is my application PHP, column, this guy, this tag. So that's the first part. Then I will now put space, the name I want to call it. So I want to call it, it's supposed to do gender, column, latest. So I said, this application with this tag, I want you to give it, I want you to tag it with this name and this tag. So if I come back to Docker desktop, you can see that I have gender and latest now. So it's just like me copying the image, replicating the image. So this is the one I want to push online. So I can now run this Docker push registry repo name tag. So I can now say, the name of my repo is Femi 15. Let me confirm. Femi 15. And I'm removing this guy. I'm putting it as push. So I expect to get that login error. So it said that the push refer blah 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 blah. So let me now login, Docker login. And then try again. So the push refers to repository docker.io does not exist. Oh, sorry. You can't give up now. Docker tag this guy. Let me tag it this entire thing. Okay. Then I'm pushing this guy. Yeah. So he's pushing now. So let me just tell you what I changed, so that you can follow through. Just a moment. Let me see if it has pushed successfully. Now you can see that on my Docker hub repository, and I have Femi/gender there. So I can now copy this guy and go to my Kubernetes and say that this is the guy I want to deploy. In my image, where's my image? Say this is the guy I want to deploy. And that's what Kubernetes will deploy. So let me run this command, and then I will now tell you this step-by-step process. Okay. It's already creating it. Okay. So it's like it's terminating some, it's recreating some, just replacing. What I did is that's finished creating it. So what I did was, let me show you the step. You already have your image called PHP from my own side. I have the image called PHP. You have a Docker desktop application, Docker desktop account. So what you will do is to retag your image with another name, and this is the command. On your inside your code, inside the code directory, you can see that I'm inside the code directory. Yeah, so you do Docker tag. The name of your application is PHP. Column, the name of the tag The name of the tag is 8.2 Apache space docker.io slash your username slash the name of your. I can also repeat the name of this application and the name of the tag. I can repeat it here. Okay, so let me isolate this command and then explain it in isolation. Copy. Let me put it in another file. And just put it here. So this is the command that I ran. Let me break it down. I have docker tag. So the command is in 3 phases. Docker tag is like, I have this. This is what everybody has this already. You have an application, and your application has a tag, right? Right? We have 5 minutes, and we'll be over with this class. Just 5 minutes. I know you are tired already. It was just 5 minutes. We have. Okay, you're not tired. That's nice. You have a lot of energy. All right. So everybody here has a Docker image. And your Docker image, if you check it, it has a tag. Right? So now, what you want to do is, this Docker image, you are using it locally. We want to copy it to something we can send to Docker Hub. Is that okay? So the command, the Docker command to copy it is for us to tag. Is Docker tag. Then the name of my app is PHP. The name of my tag. My application is PHP from here. The name is PHP. The tag is 8.2 Apache. The tag is 8.2 Apache. What I'm using to separate the two is the column. Do you understand that? So we understand it to this level. This first 2 lines, we understand the first line. Docker tag is the command. The name column tag, right? Then the next thing is where we are sending it to. So we want to send it to Docker Hub, which is this docker.io. On Docker Hub, my username is Femi15. And I want the application, instead of PHP, it is bearing on my laptop, on Docker Hub, I want the name to be gender. And I want the tag to be latest. I can as well copy this guy and put it here. It's still the same thing. It's just the name I want to name it and the tag I want to give it. Are we clear? So are we clear? So if you go to Docker Hub, are you logged in on Docker Desktop? If you are logged in, you will be able to see your username from here. You can see this Femi15. After your username / you can repeat that if you want it to be the same name. Or if you want to change the name, you have opportunity to change the name. So these 3 lines, I'm just joining them together. Yes, I replaced my own with gender. So we are just joining them and separating them with spaces. Those 3 commands. So it becomes a single line. But you understand this single line now. So let me copy it and let it be part of the thing I'm going to send you later. You see all these stuff that I've even prepared. I was unable to check them out because it will slow us down. So let me. So it will be part of the command I'm going to send to all. You can see all this one, brew, install, kind. All these ones. This one. Yes, you should run it. You should run it. So if I go to Docker Hub now, this is my Docker Hub online. You see, this one is local on my machine. But this is the one online. This Docker Hub repository is the one online. So everything, you can see all these ones are the things I have put there in the past. The new one that I put today, added today, is this gender. So if I now come to Kubernetes, so Kubernetes will go to Docker Hub to pick stuff by default. You can ask it to pick from AWS or GCP repository. They have their own too. They have their own repository too. But you are going to be paying for those services. So everything I'm teaching you today is things that you can do for free. And startup like free things. At least build your idea with free tools. Once you now start making money, then you can start using the paid tools. So by default, Kubernetes will go to Docker Hub. You notice that, look at the name of my stuff is Femi/gender. And on my Kubernetes code, I just put Femi/gender. I don't bother putting Docker Hub / anything. So it is smart enough to know that let me go to Docker Hub first to look for this particular image there. And I put it there and I ran deploy and it deploys. And that's all I need to do. And that is the entire life cycle. So whatever we are now changing now, you are changing some things in your code. As you are updating and iterating, you are testing it on your Docker desktop locally, not Kubernetes. Once it has worked locally and you are happy with what you have built, then that image, the last image you deployed, is now what you are sending to Docker Hub as storage. You are not, your code base is going to GitHub. You are sending your code base, the raw code, PHP, HTML, send that one to GitHub just for storage. But the image you want to run, you are sending it to Docker Hub. So now, with that image, you can run it on a VM with Docker desktop, with Docker. I said Docker desktop again. With Docker, you can run it on Kubernetes. You can run it on ECS. You can run it anywhere with that same image. And you don't have to do any further engineering. It will work the same way it is working on your local machine. It will work exactly the same way. Do we understand? Have we gained anything today? Trust me, if you come for an interview and I'm the interviewer and you show me this knowledge, I will hire you. Really. I'm serious. I'm serious. And the fact that you're not fed up. the fact that you are not tired, I'm surprised. Like the fact that you can stay true till now, it shows some level of well done. Okay. Yes. Oh, just put that your name slash. Just yes, that's all. Just do your normal Kubernetes deploy, just to so that you can pick that latest image, and that's it. So, any further question? That will be the end of the class. You've learned. So today, let's do a recap. We did 3 stages. We built a custom application. Then we containerized the application, and then after containerizing, we pushed it to Docker Hub. Then we created a Kubernetes cluster, and the cluster came with nodes. Then using our YAML files, we created deployments. The deployments created the pods. We created services to talk to the deployment and then ingress. And then we asked our deployment to go and pull our image from Docker Hub and deploy it to Kubernetes. And that covers the entire software development, from development to packaging to deployment. It covers the entire life cycle. So I'm sure there's nobody we are leaving behind. We all have good starting idea, at least, to go back home and build another thing from scratch. And I will advise that we have a community. The community should be, maybe anybody ran into problem, you need to be unblocked, you should be able to drop it in the community, and people can easily unblock you, and then other stuff. So that's how people grow in the industry. You are stuck, you go to Stack Overflow, you put your problem there, somebody sees it, tell you the solution, and then you are good. And today you even have AI, so you don't need to wait for somebody. Just drop the problem. If I have any error, copy that same error, drop it to ChatGPT. It tell you the way out of the error, and you are good to go. All right, no question. Thank you very much for today. God bless you.